हेलो फ्रेंड्स। आज का एक बहुत ही थर्मोडायनेमिक्स का एक बहुत ही प्यारा सा सवाल है जिसमें हम हीट इंटरेक्शन और इंटरनल एनर्जी के चेंजेस के बारे में, किसी सिस्टम में कोई अगर प्रोसेस अकर हो रही है तो कैसे हीट इंटरेक्शन होगा वो हम कैलकुलेट करना सीखेंगे, और कैसे इंटरनल एनर्जी के चेंजेस होंगे उसको कैसे कैलकुलेट करते हैं वो हम सीखेंगे। दूसरी चीज़ हम यहाँ पे ये भी देखेंगे कि यहाँ जो स्पेसिफिक हीट एट कांस्टेंट प्रेशर है वो टेम्परेचर डिपेंडेंट है। ठीक है, तो कभी भी ऐसी अवधारणा नहीं होनी चाहिए कि केवल आपकी कांस्टेंट स्पेसिफिक हीट हो सकती है। स्पेसिफिक हीट आपके टेम्परेचर पे डिपेंड कर सकती है। चलिए देखिए सवाल क्या है। सवाल में दिया गया है आपको कांस्टेंट Cp यानी कांस्टेंट हीट, कांस्टेंट स्पेसिफिक हीट एट कांस्टेंट प्रेशर, वो उसकी वैल्यू दी गई है 2.093 प्लस 41.87 अपॉन T प्लस 100 जूल पर डिग्री सेंटीग्रेड। गुड। एट कांस्टेंट प्रेशर 1 एटमॉस्फेरिक प्रेशर, इस सिस्टम को हीट किया जाता है 0 से 100 डिग्री सेल्सियस पे। इसके दौरान उसका वॉल्यूम 2000 सेंटीमीटर क्यूब से 2400 सेंटीमीटर क्यूब तक इंक्रीज करता है। तो आपसे पूछा गया है कि व्हाट विल बी द हीट इंटरेक्शन एंड व्हाट विल बी द इंटरनल एनर्जी इंटरेक्शन। सो वेल, let us solve this question now and we will learn a very nice concept over here. See here that what is change in energy, dq. You know, dq is equal to cp dt. Cp dt means what? Because very simple concept is that you can see here Cp is specific heat at constant pressure, and you can see the unit is joule per degree centigrade, and temperature is changing here. That's why we can observe that Cp dt will be the formula for change in or interaction of heat from temperature T1 to T2. In major cases, you often observe that Cp to be constant or independent of temperature, but in this particular question, this is the beauty of this question, that it is dependent upon the temperature. So let us now solve. If you are known about this formula, it will be very much easier for you to solve such questions. See how this question will be solved. Temperature 0 degree centigrade to 100 degree centigrade, lower limit will be 0 degree and upper limit will be 100 degree. No doubt at all. Cp, the value of Cp is 2.093 plus 41.87 divided by T plus 100 dt. You know, a very simple mathematics will be used here, that delta Q, change in heat of the system or heat interaction of the system, will be T 2.093 dt. dt will be integrated to T here, so this will be 2.093 T, lower limit is 0 and upper limit is 100. Now the second integration, you know 1 upon x is integrated to log x if it is integrated with respect to dx. So here T plus 100, so no doubt at all, this will be 41.87 log T plus 100 with upper limit, lower limit 0 and upper limit 100. Okay, now let us solve this. We will get 2.093 into 100 minus 0 plus 41.87 log, see here 100 plus 100 and minus log, you know, upper limit minus lower limit will be implied in this function. So here it will be 100 plus 0. If you solve this question, to be very clear, you will get 2.093 into 100 plus 41.87 into log 200 minus log 100. Okay, now here we observe 2.093 when multiplied with 100, we will get 209.3 plus 41.87, and you know log m minus log n is log m upon n, and here 200 upon 100 will become 2, so this will be log 2. If you will solve this very easily, you will get the value 209.3 plus 41.87. Such values should be remembered by us. It will be helpful for us to solving the question in competitive examinations. Like log 2, the value is 0.693. So you just multiply 0.693 over here. Without calculator, you will be able to solve this question. Okay. Now if you will multiply 209.3 plus here 41.87 when multiplied with 0.693, so definitely it will be near about 29 point. What will be the exact value? Let me see. Let me check. The exact value is 29.02. Okay, 29.02, and just by adding these values, we will get 238.32 joule. So this much amount of energy, heat energy, is added to the system. Now why I am saying that this much amount of heat is added to the system? Because you can see the value of heat is coming to be positive, and whenever heat is added to the system, it comes out to be positive. When it is liberated from the system, it comes out to be negative, to be very clear. Now let us move to the next part of this question, that is what is the change in internal energy. Okay, delta U. Okay, so for calculating that, because for a process you have learnt the first law of thermodynamics, that is dq is equal to du plus dw. dq is the change in heat or heat supplied to the system. du is the change in internal energy. dw is the work done. So ultimately, if you have to determine, you must be known about the any two parameters to determine the third one. Here we are available with the Q, change in heat energy, that and heat supplied to the system. Now in question we can observe pressure and change in volume is given. Pressure is given 1 atmospheric pressure and volume 2000 centimeter cube to 24. So we remember a very simple formula, that here PdV work has been done. First of all, we will try to calculate this dW, change the work done on the system. So let us do that. dW is equal to PdV. Now we have the pressure, 1 atmospheric pressure, and you know it must be converted into Pascal, and the value of 1 atmospheric pressure is 1.013 into 10 raised to the power 5 Pascal. The volume, you can observe 2000 to 2400 centimeter cube. A very dangerous thing is here. You have to be very careful. Whenever you see, be careful and convert all the units into meter cube. And very simple, to convert the centimeter cube into meter cube, you have to multiply by a factor of 10 raised to the power minus 6. So here we have 2000 into 10 raised to the power minus 6 as lower limit and 2400 into 10 raised to the power minus 6 as upper limit. And the remaining factor is dV. Now I have taken this pressure out because the pressure is constant. It is not the function of volume over here. That's why this is taken to be out from the integration factor. Okay, if it is depending, then it must be considered with respect to volume. Okay, now 1.013 into 10 raised to the power 5, the dV is integrated to V with upper limit and lower limit to be lower limit to be 2000 into 10 raised to the power minus 6, and this is 2400 into 10 raised to the power minus 6. Okay, now see here, just we have to solve, we have to do the simple mathematics. 10 raised to the power minus 10 raised to the power 5 into, here I observe that in upper limit and lower limit a common factor is 10 raised to the power minus 6. Taking it directly to out of the bracket, I have a very simple calculation, that is this one. If we will solve, we will get 1.013 10 raised to the power minus 1 into 400. Well done. If you will solve this, you will multiply this, you will get near about value 40.52 joule. This is also positive. It means what? It implies what? Heat is being supplied to the system and system is doing some amount of work, expansion work. You can observe here, this volume is increasing from 2000 to 2400. Itself suggests that it is a kind of expansion that is going on the basis of heat supplied to the system. A very nice concept is here. Now we have to calculate du. As you know, we have already learnt that dq is equal to du plus dw. Now the value of dq 238.32, 238.32, du I have to determine, dw I have 40.52. now we will get the value of du to be 238.52 minus 238.32 minus 40.52. Okay, now if you subtract this value, what you will get? Let me check with the help of 238.52 minus 238.32 minus 40.52 is equal to 197.8 on the joule. Now here what we have learnt that how to determine the change in heat energy whenever the expansion is taking place, expansion or compression is taking place at constant pressure. Here we have used the formula CPdT. After that we have used the PdV formula for calculating the change in work or work supplied to the system, and after that we have used the first law of thermodynamics for calculating the change in internal energy. Thank you.